Okay, get the graph for the consumption and MD. Use combo. You can use also combo or another graph to show the relationship between consumption and audit and maximum demand. Okay, something like here. Make sure to put the name for the title. Okay. Okay, this one is a graph for the consumption and maximum demand. Okay. So from here, there's the information. For example, for load factor, 0.45. Okay, something like this, 0.42. This one is the simulation value for your understanding on how to produce the graph from the data that we get from the bill of electricity during the energy audit process for the desktop data collection. So you can also, because the load factor, sorry, we can get the value for the load factor here. Load factor is total of the electricity consumption divided by this one, maximum demand multiply with hours, 24 hours, and the numbers of days in that particular month. So we consider 30 days for every month. Easy to calculate. Okay. Sorry. Okay. This one is the load factor. Load factor. Okay. So we can add another value for here. Load factor. Too small. So we can design another type of to see the correlation between consumption and load factor. Okay, something like this for the consumption and a load factor. And then we can also analyze the performance of the load factor to the maximum demand, because two of the parameters we consider in the formula to get the value for the load factor, right? So when the load factor is improved, and that show the good practice for the to balancing the consumption and to reduce the maximum demand. Something like this, okay? When the when okay, sorry to change in October, for example here, or in September, the load factor is improved, right? Compared to August, okay? Improve because of the consumption is reduced, and then the kilowatt hour is also reduced. That's why the load factor is improved. Okay, that's the one of the analysis that we can put on the report. So in order to improve the load factor, so must reduce the consumption of the electricity and the maximum demand value. So by this one, when this balancing come to the practice one, and we can see the improvement of the load factor. Load factor is important to the utility such as TMB, because they can reduce the tension of the generation side, so that the generation doesn't work in tension period. So the peak demand, for the total peak demand for from the client or customer or consumer, can be reduced. Okay, where to see the total maximum demand for the Peninsula Malaysia? We can go to the website, GSO website, GSO. Okay, here, grid system operator. This one, the GSO started in the IBR system under Malaysia Energy Supply Industry. So during the regulated period one, so this GSO has been set up so that we can see all the data from the power station information, system generation, system demand, okay, this fuel mix, etc. Code, grid code here, okay, that's all about the GSO information here. You can see the code of conduct for the system grid, okay. So we can see here the system demand. System demand. System demand is mean the total demand for the Peninsula Malaysia. Now at 10, we have about 40,000. This is current system. Saturday at 10 p.m. Here, the total demand for the Peninsula Malaysia right now is about 14,793 megawatts. Okay, this one is the total demand. So the highest record for the demand last month, for the last month, is 18,800 megawatt. Okay, higher energy record. This one is energy record. Energy record, megawatt hour. So megawatt hour. This one is maximum demand. Maximum demand. 20 megawatt hour for 1 day. Okay, for 1 day is 394 megawatt hour. for 1 day. We can see the profile here for 1 day profile, 24 hours profile for total. Okay. So for those who are interested to do some research in regards to the power profile, and you can get the data here. Also, this website reflects to the generation data. Okay, provide the power station information, the system generation. This one is the list of the power station in Malaysia. So total installed capacity, something like here. Okay, for example, in Peninsular Malaysia, the total installed capacity is 22,858. Okay, the maximum demand something like 800 just now megawatt. So how many percent the reserve for this one? How many percent reserve compared to the total installed capacity? So when the consumer, for example, from the commercials, from the industry that use very huge of the electricity consumption or the capacity load ni, okay. So when we improve our load factor, as well as we reduce the consumption of electricity and reduce the maximum demand, so we contribute these consumer contributes to maximum demand, total maximum demand, and reduce the stress for the generation to supply. Okay, so when this kind of happen, so government doesn't have to put the plan to install any other installation generation in Peninsular Malaysia. It's not, then we need to add to develop many more generation power supply or power generation in a peninsula. Okay, you can explore more all about the peninsular data for the energy consumption for the generation side. Okay, here. All right. Now, we finish for the desktop data, and let's move to room data survey. Okay, this one about the benchmarking. So we got the baseline lah, set up baseline, step down data collection, establish relationship, energy and input related factor. So we have done about this one, data collection. So set up the baseline EEI for the organization. For example, the factory, the simulated data, we got their EEI, or for the commercial, we have their EEI. So monitor of the change beyond the baseline. So that EEI, for example, 2019 as the baseline, okay? Or we average 2 years, 2019 and 2020 as the average value for both years, okay, to be the baseline for us to make the changing or to make energy conservation measures or to practice energy efficiency so that we can see the performance. We measure the performance from the baseline to the current performance in 2021. That's the benchmark means for the consumer. Okay. So benchmark is important to measure where are you now, how good are you. That's why you are this position, and that's about the benchmarking, the basic one. Okay, establishment. So benchmarking categories for the buildings as the overall service, air condition, lighting, lift. So for the lighting, also we have the external benchmarking. External benchmarking means the benchmark to another organization or to the standard, etc. Okay, for the internal benchmarking based on the equipment, for example, chiller 1 and chiller 2 in the plant room, cooling tower 1 and cooling tower 2 for the same building. We got several type of the system over there or equipment. So these, for example, pumping 1, the motor 1, Moto 2. So compare the performance of those motors so that we can get idea on how to improve this kind of the motor performance. Okay, and also we back to the external one as well so that we can compare to the standard or compare to the manuals or manufacturing standard as well. Benchmarking, so external benchmarking for the overall. So this one is the examples in a guideline for the energy efficiency building. So for the building that measure 136 and below, so they can be energy efficiency building. Leo, this one 2001, the building Leo in Putrajaya, energy conversion building, the diamond one, 2006. So the BEI or EI for this building is 85, and we got Geo building, Malaysia Green Technology Corporation in Bangi. So the first design for the Geo building, they record the EI is at the time 65. The EI was 65, but they put the solar when the solar energy generation put on the building, so they got minus for the EI, minus until minus 35. Lighting. So for the lighting, this one is specific. Also can be the external benchmarking because we benchmark to the Malaysia standard MS 1525. So find the standard. Okay, you can get in a PDF. So wherever you go for the room data survey later on, okay, make sure you compare to the Malaysia standard. Okay, this one is the list of the example here in the tables. Office, for the office, in the left side, this one is the measurement and recommendation for the MS to S. For example here, lux, the average lux in the office is 359. So the M square, okay, for the office is 11.2, And the standard say the lux level for the office must be within 300 to 400. So this one with this was of the office. So this one, the reading for the 359 is within the standard. So for lobbies, the actual reading during by using the lux level is 400. And what's the standard say? The standard put 100 for the lobby. So this one can be one of the losses for this building. So as the auditor, we could suggest some improvement for this lobbies area in order to reduce the lux level so that we can save the energy. So for example, these lobbies use more lighting over there. Okay, so we can put the option or the solution to reduce the numbers of lighting for the lobbies, and we measure the lux, remeasure the lux so that we can setting lux level within this 100 value. So another example for the canteen. For the canteen, so the actual value, the measured value is 340, but the standard, when we refer to standard say that there is only 200 lux level enough for the canteen. So must be something to reduce the lux level, and we can reduce the energy consumption as well. Internal benchmarking, for example here, the comparison between type of we call it type of chiller. Okay, this one is an example. You can go to this website to see the benchmarking or to have the guideline for any related what we call it program and the green program from the Malaysia Green Technology Corporation. Detail audits, okay. This one, the examples for the detail energy audit, the data logger here. Okay. This one is power logger, and basically we use this power logger to measure at least 7 days, 7 days energy performance, to record the any related information to the energy. For example, maximum demand, energy consumption, okay, and we can get the profile for 7 days. Okay, this one is the process for the room data survey to measure the lux level, temperature. Okay, I just want to measure the temperature, key off meeting. Just want to measure the cooling system to visit the plant room. This one near the MSB. Okay, room data survey. It's the method to review design, drawing, data, room selection, a record parameter in the room. So in the room, we can record the parameters such as lux, number of lighting over there, temperature and relative humidity, CO2 level, number of this one PC, for example, the load one, and other equipment. Room data, lighting data, general equipment. So to conduct a lighting audit, you will first take basic lighting information such as number of light, okay, location, can refer to M&E drawing, okay, or you can ask the owner of the building, and operation hours. So detailed information will help you to understand how you are currently spending and the potential saving available from the lighting efficiencies such as conduct room data survey, measure lighting level, purpose of the improvement on how to reduce number of light, okay? Reduce the number of light here. So wherever we find that's the lux level is more than compared to the standard. Okay, for example, 400 and standard say only enough for the 100 lux. So that's some improvement. Then the improvement can be the reduction for the number of light over there. So look for more information technology, control, reducing operation time, etc. Okay, this one the examples lighting data. Okay, here for example room description, car park, corridor. So lighting numbers for in car park 122. Type of lamp, fluorescent lamp, FL, CFL compact lamp. Okay. So what? How many watts? The standard say, or you can measure the watts, or you can find the type of lamp, and then we can consider the rated value for the power to be recorded here. So number of faulty lamp, no. N for no, Y for yes, or type of control, manual or can be control. Test status reflection, okay, reflection. Operation hours, okay, you can ask the owner of the building or from the record one. So either this one is what's the value for the operating hours. So how many hours this those lighting has been used, okay, from the certain area. So you also may record this operating hours so that we can calculate their consumption later on. Okay, so from the rated one, for example here 28 watt multiply with the hours consumption. So we can have kilowatt hour to be energy consumption. For example, 8 hours a day. 8 hours a day. So we can get here 28 watt multiply with 8. So 0.22 kilowatt hour, right? Okay, the unit, how many unit here? Multiply with unit, 122 unit. 27. So for this car park, for 1 day, the energy consumption use is approximately 27.33 kilowatt hour. Okay, it's the same activity happen for the 1 month, so multiply this one with 30 days. And we can get the value for this lighting in area of car park area. So can get the consumption for the lighting for the car park area in 1 month. One 9.84 kilowatt hour for 1 month. So how to measure the lux level? Okay, that get the 3 point for every single lighting that we have, okay, and get the average one, average the reading and compare with a standard. So for example, this lighting one, okay, of course they have 1 or 2 or 3 light lamp over here, and just measure the 3 point for every single this compartment of lighting, okay, so we can get the average value for these 3 point for every single area of lighting here. So after that, when we got the average for example, this lighting 1, 2, 3, and 4. We have 3 point of every single these four area, right? So for the total area in this room, you can put every single average that we have to be another average for the final one, and compare to the standard. This one, the form, the example form for the room data survey. You can also make by your own, put on your Excel. Easy to make the calculation after that. Okay, for example, level for the building that have multiple level. So level G, ground. Room number 1. Row description for the room number 1, lobby. Number of people over there for the lobby. We have imagine the lobby in FKE. We have total of staff in the lobby 3 person. So large level over there. So maximum, we can also measure the maximum and minimum one, or we can have 3 reading, and get the average for the large one. For example, 300. So temperature, actual temperature. Yang ni tak perlu, no need. Actual, so 23. Around humidity, for example, 76. CO2, 500. This one not related. Color of wall, white, for example. So remark, you can put any remark. Rainy day or sunny day. Okay. or crowded, number of people here more than 10 or more than 20. That one is for lobby. So G, again G. So lecturer room, number one. Okay, so number of people one. Large levels, okay, the average one, 200 for example. And all this one, we compare to the standard. Okay, so specific for the lighting, we're gonna have this form. Okay, G, number of room, lecturer room, number of lamp, for example, 4. Number of fitting 4, lighting equipment, type of lamp, fluorescent lamp. The watt plus ballast can be 40, standard 40 watt. Type of control, no. Diffuser type, ni no need lah, no need. Operation time weekdays, start 7 to 7, or Saturdays tak ada. No, that's why is for weekend. So this lecturer doesn't come to UTM for weekend. Total power consumption. So multiply 40, multiply with 4 number of lamp, multiply with 12 hours. Multiply this one for 1 day, So we can get the value for the total consumption. Lighting, energy consumption. So after that, when we get the total energy consumption in one building, and we can put on the energy breakdown over here. So type of lamp, type of lighting, fluorescent, FL, halogen, LED, so HIDL, something like this. Fluorescent lamp, okay, we have LED, we have T5, T8, the very common one, okay, in the building. So compact fluorescent lamp, CFL, something like this. There is CFL. The type of CFL can be up to 26 watt. CFL for the LED, we got the also LED for the CFL. Okay. Halogen lamp, we can find this halogen lamp in a stadium, in Dewan Chancellery, UTM. Okay, during the examination, the lux level is not enough for student, right? When using this halogen lamp, LED. So many type of LED right now for the lighting. So we can find many more in the market today for the LED. Okay, when we compare to the conventional lamp, the LED one or the compact one is better. And for the CFL, conventional CFL compared to the LED, okay, something like this. So more watt can be reduced from the CFL to the LED bulb. So we can have the LED for the 5 watt, 6 watt right now. Yeah, save big white LED holiday. System performance when compared to the MS1525, okay, for example, restaurant. And make sure when you visit the shop lot for your assignment later on, so you measure the lux level, okay. You can have the reading of the lux level from your apps for your phone by using lux level apps. So always refer to the MS. These tables also show the comparison to the MS, the real measured value to the MS. So from here, we can see there's a lot of opportunity to get saving from the lighting system when the lux level is over compared to the Malaysia standard. For example, here, meeting room 2, level 15. The lux level is within 300 to 400, and the measured value is 800. So something wrong with the arrangement of the lighting in the meeting room 2. So must do something, and as the auditor, we must suggest the solution on how to reduce this lux level, or we can put the suggestion for the delamping, which means to reduce the numbers of lamp in the room. Okay, for the remark here, overlit means this area is over compared to standard. The lux level is over compared to standard, overlit. And if the relative comparison is a little different only, and we can put okay. Okay, so underlit, not enough level for the lux, not enough level for the lux. Okay, so underlit, we can put remark something like this. So by using the room data survey, we can get the energy data from the lighting only. For example, here, when they collect the lighting, and we can total up all the lighting quantity here. For example, fluorescent 36 watt, about 5,426. Okay, fluorescence for the 18 watt, 300 something. Okay, compact lens FL 744, and a metal highlight spotlight, this one 22. So we can total up all these, calculate, multiply with the quantity, multiply with the hours of the consumption, and we can get the total load in a kilowatt hour. Operation hours is 9 point something. Okay, so energy for 1 day from the lighting system is 2100, and we can multiply with the numbers of days. Here is the working days. 250 days. So we can get for the 1 year, the total consumption from the lighting is 500,000 kilowatt hour. Recommendation in lighting system, okay, replacement magnetic ballast. This one is the recommendation, or we call it ECM, energy conservation measures. Delamping, okay, delamping, reduce power luminance, install timer switching or occupancy sensor, optimize of daylighting, okay, change fluorescent lamp TLD to the energy efficiency lamp T5 or LED. Here, okay, for the conventional fluorescent lamp, 36 watt, change to the LED 9 watt only, okay, and then after that we suggest with the ROI information, return of investment, so that the client can be approached by to have confident level in order to invest for the LED. Okay, this one, this slide show the detailed calculation for the investment. Okay, so can come up with the last payback period for the office and a figure for the parking and the office to change from 36 conventional fluorescent lamp to the energy efficiency T5. Okay, the ROI, the simple payback, we can calculate something like this. Even for this parking area, okay, when we change or retrofit program, do the retrofit program from the conventional fluorescent lamp to the EET5, it will not, is only within 5 months, this customer or client will get their payback period. The potential saving is 37% for 12 hours time operation by change from the conventional fluorescent lamp to the EET5. Okay, this one, another example, change for metal halide to the LED spotlight, okay? Conventional LED to the LED spotlight. So payback period within 2 years only. Ya.
Apa maksud dengan payback tu?
Payback period. Total your spending for the investment, and you can get the total investment back during this period. For example, here 2 years, and your investment is 55K. Okay, by reduction of the electricity bill, and you can get this investment value back within the. Faham ke?
Okey, dah faham. Terima kasih.
Take this one. Okay. Existing. So this one, the existing lamp, okay, a conventional spotlight, existing lamp. The numbers of existing lamp is 22. So we have 22 units of the lamp. Okay, the power for every single lamp is this one is total total power. So one unit for 1000 watt over here. So the total unit of power is 22 kilowatt, and multiply with this one is total hours yearly. Okay, so multiply with total hours yearly, we can get the annual consumption for this existing one. And we propose to use the LED spotlight. So the new LED spotlight, okay, the power, total power for the 22 unit is 2.6 kilowatt only, and multiply with these operation hours. Okay, so for the new proposed LED, only use 11,500 kilowatt hour per year. And unit cost, okay, for the kilowatt hour, for example, we refer to the tariff. For example, tariff C1 0.365, the new price rate since 2014. So multiply with the value of the tariff. Again, annual energy saving by the baseline annual consumption minus this one minus this one. Again, we can get the saving one. So annual cost saving multiply with the tariff rate, and we can get the saving for 1 year. For the yearly saving is 27,000. So the investment for this one 55K. So the saving 55K is the investment. Okay, so the investment over annual cost saving, you can get 2 years payback. So simple payback is investment over annual saving. So you can get approximately a 2 year. Okay, this one investment over annual saving. General equipment form. Okay, this one for plug load equipment. For example, level 1, room number 1, lecture room. Type of load PC. So rated of PC 40. Unit 1. Loading factor, no need. So we can, with this, start from 7 to 7. And so no total consumption, okay, 40 multiply with 12 for the working days. So another fan, for example. So do the same way on how to calculate the total power consumption, kilowatt hour. This one for cooling data. air velocity meter, climb meter, temperature, humidity, CO2 meter. Okay, this one is the picture for the CO2 meter. Air velocity meter to measure the airflow. Okay, temperature and humidity. This one large level, temperature and humidity. This one climb meter. This slide show the logger for the temperature. Logger for the temperature. But when we do the room data survey, we can measure one of a value, one of measurement. For example, here room data survey for the lecture room. Okay, we can measure one of temperature in this room. For example, 33 degree. Okay, so put in the form the value, write in the form to the degree for the room number 1, level 1. Humidity, temperature. Okay, this one the logger. When we have humidity logger or temperature logger from the building management system or control system, we can have this something like this one. Okay, so auditor can also refer to the building management system if the sensor is available. Okay, if not, then the auditor need to measure by their own to get the value for the temperature and humidity. Okay, if something like this can be taken from the control room. So finding, we can have this one, total lighting, total number of computer or other equipment. Okay, imagine that this one we do room data survey in FKE. Okay, so we have lighting, computer, other equipment total. So average of the temperature and relative humidity, CO2 levels. Why CO2 level? We do the measurement for CO2 level because CO2 play the important remark for reflect to the cooling system. Okay, when this CO2 level is higher, then something wrong can be detected from the cooling system that we have. For example, chiller or AHU, air handling unit. So we need to do something to get fresh air enter to the building so that we can balance the value of the oxygen or level of the oxygen to the level of the CO2. Okay, so you can get enough oxygen or fresh air in the building so that people can have a good a good what we call it for the a good level for the oxygen in the building. Okay, for their any activity. So from here, we have total number of lighting. Okay, finding for must be something like this for the room data survey. Okay, let's move to the to the, what we call it, the Excel data that I have provided for the last class. Okay, where is it? Okay, before that, we take 5, boleh? Take 5. Okay. So everyone, please open this Excel so that we can do some analysis together. Okay, this one will really help you to do your individual assignment, right? Okay.
Verify. Doktor,
Ya, Kalisa.
doktor memang tengah tak cakap apa-apa ke saya yang tak dengar?
Kita take 5, take 5.
Oh, okey, okey.
Rehatlah Kalisa.
Okay, for individual assignment, anyone of you already get the home data for the something like this? Ada tak yang dapat? Or you didn't know on how to access to the smart meter in the MyTMB? Okay, for those who are able to access to MyTMB, okay, you can click here, view account detail. When you want to approach the locality, okay, or your neighborhood, or your neighbor, you can, and they allow you to use their MyTMB, okay. So just access the account and click to view account detail. View account detail. And scroll down to the bottom one, and you can see here the smart meter, external link to the smart meter. So click smart meter. Okay, so the link to be appear something like this. Okay, so that's the dashboard for the smart meter. And under my energy, there's the cost here, the under my energy, cost, usage, and impact. Okay, so this one, when you click cost, you can get the cost and projected cost, the current cost, something like this. And when you click usage, you can find usage. And when you click impact, so that's the calculation for the CO2. Okay, this one, the usage and the cost under the dashboard for the smart meter. Okay, and now go to the usage and click 1 year, download the Excel 1 year. You can get the bill for 1 year, something like this. Okay, bill for 1 year, and get the total monthly 1 year. And after that, create the graph for this one. Okay, a graph something like this to measure. So for the residential in Malaysia, we have a block tariff. So 0 to 2 kilowatt hour, that's the one block, and this one is another block, this block, third block, and fourth block. So this block tariff, you can create this chart, something like this. So we can see where the performance of every single month for this home. And also you can calculate the EI or home efficiency index by total up all the 12 data or 12-month data. So over the area of the home in a meter square. So when you got the information in square feet and suddenly change to the meter square, okay, in order to get the home energy index or home efficiency index, the total of the kilowatt hour for the 12 data that you have, okay, over the area of the home. Okay, this slide show the performance for the 12 data started from January to December. Impact for the CO2. Okay, one usage, click usage, and you can get 1 year, 1 month, and 1 day. You can download all the information here. Here, transfer to the Excel. And now, click to 1 day profile. Okay, add the usage under the usage, 1 day profile. So we're gonna have the 1 day profile, something like this. Started 12 to 11. Okay, so for every single half hour from the smart meter record. Okay, download. For this consumer, okay, from here we can read the activity. Okay, so we know that this customer doesn't have people from 8 to 5 or from to 4 every single day, because both or maybe all people in the house have their activities outside there. For example, go to class, go to work, etc. Okay. So we can see here, we can monitor the performance of the 24 hours load here, at least less than 10% compared to total. Okay, so if there is something abnormal reading here, so something during no people in the house, and something wrong with the activity, so we can advise, okay, that's the losses for that, and can recheck for the system in the house. So that's the losses can be mitigated. Okay, from here download, transfer to the Excel, and take the total one for every single day. So at least you download for the 7 days, 7 days. And the data that I give you for the last class is came from the smart meter. Okay, this slide show the examples of the 7 days. Why 7 days? Because in the standard from the Energy Commission for the energy audit, the minimum record to get the profile, to know the profile, to understand the profile of the energy consumption from any installation. That's the minimum requirement for 7 days. And if you can get for 14 days to verify the another 7 days as the verification, that's the good practice for the load profile reading or load profile analysis. So here is the 7 days data, and you can create graph for 7 days, total 7 days graph, as we did for the last class, right? Something like this for 7 days, and analyze the data that we have, analyze the profile. So from here, we can see there's something here in Saturday, okay? So here, there's the opportunity to reduce the consumption within this period, because there's a 2 days that show a minimum record for the consumption. Okay, so must be something wrong with the equipment, or people went out and with no equipment shutting down inside the house. So this area with the heavy consumption of the electricity, and when we do the energy audit for the residential area, so we can ask their activity for this period. So what kind of the equipment they use, okay, during this period. Maybe they use air condition, or the heavy use of the refrigeration, okay, for the heating system, water heater, to take a shower. Here the activity for television over here. Okay, after that, do the average for this 7 day and make it simple for one line of the load profile. So do the average, and we can have this one, something like this. Okay. The average. So what's the action to be taken? So first of all, we need to do the room data survey, to record, okay, to measure. So what's to do? Collect the reading, the real reading for the consumption. Okay, at least one off consumption. For example, here, this one for fridge. Okay, so if you want to measure real measurement for the power, you can use this measurement device, or for the socket, for the socket one. Okay, you can use something like this. Or if there is no available measurement device, you can take it from the rated one, behind the device. For example, here the Samsung television, 200 watt. Okay, for the washing machine, 200 watt. But if you measure by using this one, by using this measurement device, you can get only at least 50% to 70% reading compared to the rated one. So after that, come up with the load opportuning or a load breakdown, something like this. So, for example, television, Okay, 175. So record all the power here. So how many units? The units, the hourly consumption, the time for the consumption. Okay, for example, 7 hours, 1 hour per day, per day. So make the reading in 1 day, and then we can have 1 day reading measured value for total appliance in the house. So for example here 26.99. Okay, when we back to the profile or the average one, okay, the average from the smart meter is 27. Okay, plus minus 5% is okay. Plus minus 5%. So 27.2 kilowatt hour for 1 day. And when we verify by measuring all these appliances inside the house, we get the value of this one, 29.66. It's okay lah. Okay. So after that, convert to the general one. For example, cooling system. Cooling system, okay, cooling, aircon here 3, and fan. Okay, a fan for the cooling system. Okay, put all this value to be cooling system. This one, plus, and to put as the cooling system. Heating system. Heating system, water heater. Water heater, Coway, refrigeration system, freeze. Okay. So plug load, all the plug load that we have, phone charge, laptop, etc. So lighting system, so calculate the lighting, something like this. So if you have more type of lighting, just put another type of lighting and how many units that they have. So calculate with the times that they use, the consumptions of the lighting. So make the percentage, and after that we can have the breakdown for the house. Okay, something like this. So now we know that this house have cooling system for the biggest system that use electricity. After that, refrigerant system and heating system. So lighting and plug load consume small numbers of electricity. Okay, so what to do as the energy conservation measures, as the opinion for the saving one. Okay, that's for your assignment. So try to suggest based on this option. For example, tackle on the biggest factor that contribute to the electricity consumption. Cooling system here. Cooling system, heating system. So what's the action to reduce the consumption from the heating system? And for the refrigeration system. Freeze. So how many times that the best numbers to open and close the freeze? Okay. For example, heating. So start with the zero cost measures and with cost measures. For example, here use another nature cooling inside the house, okay, to blow the flow of air inside the house, and we can setting the aircon to the 26 degree or 27 degree instead of 18 degree or 16 degree. So that's the one of the example for the zero cost measure. So set limit for the water heater to be 35 degree only, or set timer for the aircon to get shut down or close at 4:30 a.m. every day. So instead of 6, so we can reduce the consumption. And another part is which cost. Or if there is the involvement of the another cost, for example, using 5-star. So inside the 5-star, so for example, maps here. Okay, so this 5-star aircon, look at here. Okay, that's the value for the energy reduction, or compared to the 2-star. If we use this 5-star, then that's the opportunity to save about 21.5%. So from here, we can calculate the simple payback period for the suggestion to the community, to the house owner. So put the target, for example, here with the action to save, for example, 3%, 10%, 1%, 2% here, okay, and then forecast. So at least 10% saving. That's the assignment requirement, at least 10% saving. And calculate BAU, business as usual, or activity as usual. Okay, that one is the baseline. This one baseline. And after action, if there's the 10% saving, so saving per year, calculate the saving per year and forecast this one. By using the same, we have the baseline, the blue line is the baseline. And after saving 10%, you can get this one. Okay. On your report for the individual assignment, please put many more pictures that you can get. For example, pictures for the appliance. Okay, so mapping. That's your creativity on how to arrange your report. That the flow is something like this. Okay, so please add some more picture so that we can see a very good flow for your report later on. So any question? No question?
Doctor,
Yeah.
the smart data meaning only for Malacca region, or we can do for other area as well?
Right now we have in Melaka and Putrajaya, Selangor, KL.
So we can get the data from other states as well, right? Like for example, if I want to get data from Selangor.
Yeah.
Okay,
Right.
okay.
Can
Okay,
do
doctor.
that. Okay. Another question?
Dokter,
Yeah.
yang slide ni nanti ada upload kan nanti?
Tak ada.
Okay.
But I will share the recording video.
Okay, thank you dokter.
Okay. This one training training dekat luar berbayar, so saya tak nak share slide ni. Tapi you boleh dapat video, boleh tengok lah.
Doktor, nak tanya masa penggunaan elektrik tu kita estimate ke atau secara real?
Penggunaan
Yang jam tu.
yang measure tu.
Ada doktor tunjuk tadi. Yang ada list elektrik barang dia.
This one.
Yang ni. Yang tu jam, masa jam tu kita estimate ke atau yang real main?
Kalau you tak ada measurement device, so you boleh estimate lah.
Okay.
Boleh estimate.
Okay, okay.
Tapi make sure you bacalah rated ni. Yang rated ni. Kalau untuk TV, tengoklah rated dia. Janganlah you estimate TV tu sampai 500 watt. Tu
So
something wrong kat situ.
untuk kita buat room survey tu, contohnya temperature dengan humidity, so kita nak letakkan meter tu untuk di setiap bilik kan?
Yang tu one off record data je. For the temperature, bacalah masa you measure tu.
Okay. Okay, betul. Thank you, betul.
Okay.
Doktor,
Ya.
doktor yang untuk yang one off tu kan, yang doktor cakap yang one off tu, so berapa jam penggunaan tu depends on, contohnya kat rumah tu berapa lama dia guna ke, ataupun kita
Ni betul
tentukan?
lah. Ni lah. Ni yang masa 7 jam. Ni lampu meja. Contohnya you measure 5.9. So berapa jam biasa guna? 7 jam. Kalikan dengan 7 jam lah.
Okay, doktor. Thank you.
Doktor nak tanya, kalau jam masa orang tu dia guna masa guna tu orang lain kan, so kita tak tahu macam mana kita estimate ke atau nak
Kena
measure
tanya
ke?
dia guna
Tanya.
macam mana.
Okey, betul.
Biasa kalau you approach jiran, dia akan bagi tahulah berapa lama guna yang ni berapa lama guna. Tapi macam peti sejuk ni 24 hours. Kita boleh tahu dah, memang dia tak tutup pun. Kowe pun sama kalau dia ada kowe. Kalau yang duduk rumah sewa sekarang ni boleh buat dulu untuk pecahan tenaga di rumah sewa berapa. Mungkin you all dia setiap rumah akan dapat berlainan. Depend pada aktiviti dengan equipment. Ada yang berkeluarga lain, yang student akan dapat lain. Maybe plug load paling tinggi. Sebab ada kegunaan yang lain. Tapi yang saya pastikan fridge ni yang banyak sebab kita kalikan dengan 24 hours. So cuba buat dulu, dapatkan something like this for the energy breakdown, load apportioning. And another one is the room data survey for the large level, for the temperature, for the humidity. Ada soalan?
Doktor nak tanya, kalau owner tu kurang dia macam tak measure dia guna berapa jam, so macam mana kita untuk usahakan macam ni?
Dia tak measure macam mana? Penggunaan?
Bukan, contohnya owner tu macam dia tak macam tetap guna barang tu 7 jam. Mungkin dia tak sure, dia macam tak pasti.
Oh, okey. Boleh lah estimate.
Estimate, okey.
Boleh lah estimate.
Okey.
Hmm.
Ya, betul.
Okey.
Doktor,
Ya?
kalau kowe tu kira cooling system ke heating system?
Depends. Kalau tempat tu kena tanya owner dia. Dia banyak guna untuk air panas ke untuk air sejuk?
50-50.
Kalau 50-50 decide lah nak pergi heating ke nak pergi cooling, tak ada masalah.
Okey.
Ada setengah tempat dia ada baby, dia memang banyak guna untuk heating. So kita consider heating.
So ceiling fan tu kira cooling system atau cooling?
Cooling.
Okey. Thank you, Doktor.
Okey. Sama. Okay. Any other question? So dapatkan yang tadi apa? So dalam report ada bill yang 12 bulan tadi. Bill, monthly bill 12 bulan. Month bill. So record their home efficiency index. The consumption over area in meter square. So if you get the information from square feet, so make sure you change to the meter square. So get the value. Okay. So do the room data survey. Get the lighting, lux level, okay, temperature, humidity. So after that, come up with the profile analysis. Profile analysis 7 days to average profile 1 day. So from there, we can get the 1 day reading kilowatt hour. So after that, do the load opportuning or load breakdown. And suggest ECM. And forecast the performance. And calculate the ROI. Return of investment by simple payback period. If there is there's the suggestion for the cost cost of investment. So make sure to arrange the ECM from the zero cost, small cost, medium cost to the high cost. Okay. If there if no need for the high cost, then don't put high cost. Put zero cost, small cost, and medium cost is enough. Okay. Any question? Kalau ada soalan lagi boleh contact saya direct lah. Directly contact me. Or ada yang dah dapat? Tempat. So, if there is no question, I think that's all for today. We share the recording video for this class, inshallah, after this. Okay, that's all for today. Thank you. Take care.
Thank you, Dokter.
Thank you.
Okay.
Thank you.
Thank you, Doctor.
Welcome.
Thank you, Doctor.